this problem, permutations. So mathematically it's just n factorial. That's how we can see how many output will there be there. And then when it comes for all the possible permutations, we can use backtracking, and in backtracking we always use DFS, and every single recursive call we can imagine being we're calling it to our node in our tree node, so it's better to imagine this backtracking as a tree node. And let's solve this, jump into this coding right away. So integer result new array list, then we'll call backtrack method, which will be taking this result. We will be taking new array list, which will be holding the current values of permutations, and then we'll be passing our nums. And later we will just call our result. So let's define our method in here, backtrack, and it's a list of integers and a list of integer, we can say current, that will be holding all these values, and nums. Perfect. So this will be a recursive call. It's a DFS. So let's take care of our base case. So when current size equals to nums length, because if you noticed all this, because like this will be the values that current will be holding. So when the size becomes as the same this one, then we will terminate it, like return it from there. That's our base case. So result add new array list of current in here, and then return. Perfect. If not, then go over this nums, and then we don't want to revisit the same node. So in this case, like when we are imagining it as being as a tree, then we don't want to revisit, because like in DFS we see it only once. So in order to take care of it, so we can say if it doesn't exist in our contains this given num, then do the backtracking of it. So add this in our temporal, they call backtrack, send result current nums, and then do the backtracking of it. So temp, not temp, why am I using temp? It's a current. So remove the last element in here, current size -1. Perfect. So let's run our code. Backtrack. Did I misspell it? Yes, I did. Backtrack. Again, what is going on? Perfect. So let's submit it. And time complexity, it's very tricky when it calculating backtracking, but for this one it's O of n times n factorial, where n is the length of these nums. In space complexity we are using this current length, current array, which will be holding all those values in here. So it's O of n. Call stack is the height of the tree, so basically height of this current, so this is O of n.